continue the conversation. Okay, so today I want to talk about the 7 deadly sins of API security testing. Let's get right to it. The first thing I want to talk about is timing. And that's really about the aspect of starting your testing too soon or maybe too late, all depending on what type of testing you want to do and in what areas. So we've all seen this um, defect injection chart where we talk about where defects get introduced and where we find them during the testing process. Of course, we always find that at the coding phase, that's where we're going to introduce the most vulnerabilities in an API. But as we continue to go through the testing cycle, we'll find that when we don't find these vulnerabilities, usually till later in the process, usually around the functional and system testing, and hopefully getting most of them before it gets to release. But that means that there's different types of testing that we're going to do throughout that process. So we'll start with something like static application security testing, or SAST. These are where tools like SonarQube might be used to look at the code looking for vulnerabilities. And when we're thinking about this from the perspective of security vulnerabilities, what we start to find is that if it's implemented correctly, we can get a lot of the most expensive bugs, the ones at the architectural level and the design level, resolved before it ever gets into the hands of other people testing it. And that's the best time to do it when we can, but it's not always practical. It's not always reasonable to do. The developers have a majority of their role and responsibility in building code. And so what ends up happening is they don't always have the time to be thinking about how they're going to go about testing about it. As we shift more left and we start doing more unit-based testing and whatnot, that helps, but it doesn't give us the full visibility of where API security testing needs to be. So the other side of that is when we start talking about things like dynamic application security testing. And there are great tools inside of things like Burp Suite, like the Web Vulnerability Scanner, that actually have an API scanner in there as well that can really assist in this. Because what they'll do is they'll be able to send simulated attacks against the APIs to see how they function. It also allows you to explore how we might be able to taint data in different areas and validate are things like authentication and authorization headers in place? Are they being used correctly, et cetera, et cetera? And DAST can work really well for that. But the reality is DAST won't understand the application. And this is where we have to start bringing in HAST, or human application security testing. Some people like to call this manual testing, but I think that's a terrible name for it, because a lot of the HAST work that you do can be automated. You can use things like the Postman collection runner and artifact the testing that you want to do, but do so in a way so that it can be reran and retested. And you can use tooling and databases to inject faulty data. This is where API fuzzing, as an example, can be utilized, where we get able to do a lot more in validating that the things work the way they intended. And more importantly, that we can make it work in ways not intended, which is where we'll find a lot of the security vulnerabilities in these type of things. Outside of timing comes ignorance. And that's this aspect of lacking visibility into the APIs that we have to test. In many ways, this might be things like shadow APIs or rogue APIs, or sometimes even older zombie APIs, or worse yet, those undocumented APIs. And it all comes down to the fact that teams usually lack good inventory of their API assets, not just of the ones they're writing themselves, but the ones that they're consuming that we're taking a dependency on. And so it's very important that we start getting into this visibility, because when you don't, it exposes us to a lot more risk, especially on things like those undocumented APIs where we have very little visibility into it. Now, speaking about undocuments, API documentation alone can't be trusted, because developers in many ways may not always have them most up to date. Yes, there are tools that can automate the generation of a lot of these docs, but in a lot of areas, they may not generate good docs. And more importantly, there's a lot of places where they may not generate docs at all. How many times have you seen that there's documentation for things like the public-facing interfaces, but maybe not to the admin endpoints? And we really need, from an API security testing standard, to be able to actually test everything. So we need to have visibility into that. So we can't just trust those API docs alone. And this is why it's important that we also do regular API discovery as part of this process, because we can utilize the API docs and find other areas where they may not be documented and use that to get a better attack surface management of all the different places we need to do our testing. Sin number 3 is around negligence. And this is really about not doing the proper recon to be able to find everything in the APIs that we need to test. So while the aspect of not being aware of the APIs is one thing, not looking inside the APIs and understanding how it functions is a bigger problem. And this is where negligence comes in. So this comes down because people don't fingerprint the entire application and the features and functions. And that's a problem, because that means that if there are functions and features that are there that you don't know of, there's an entire area of attack surface that's being missed. And that's not a good thing. So we want to be able to find everything and anything that we can. That means that we need to, if it's a multi-role system, we need to make sure that we have access to every single role that the API might be being used in. If we're using a multi-tenant system, we need the ability to understand the tenancy model and making sure that we have things like cross-tenant data leakage and having the ability to access other clients' data when we shouldn't be able to. By fingerprinting this type of stuff, though, this gives us a better idea of how does the application function. Sometimes it might be as simple as, do you have the right licensing type that gives you the rights to see everything in the API? And these are all important things to be thinking about. Beyond the fingerprinting, though, the next thing you got to think about is, how does the API actually work? And how does the application work that consumes that API? We need to be able to look through everything, and it's something that you want to be regularly doing, because you want to make sure that we're seeing everything that the API is being exposed to. So that might be things like, how is session management and tokens being utilized? Do we find special claims and other pieces of artifact information that the APIs might be relying on? Things like feature flags and the ability to monitor the code paths, the way that they're going to go, will come from things like headers and parameters and what's in the payloads. And when we're thinking about the payloads, we're thinking about things like the data structures, because as the APIs progress to be getting built, structures may change. Hopefully it's all being properly versioned, but how many times do we have where they may make changes that could become breaking changes and they don't get versioned? And we need to know about that type of thing. It also allows us to look at things like, as data structure changes, does the behaviors alter by using old data structures or old endpoints? The whole point of recon is to be able to find all this and then to document it so that we have clarity on, what does the object model looks like? What do the payloads look like? What kind of parameters can be used? Which ones might be able to be abused? What headers could be utilized in that? If you're not doing the proper application behavior analysis, you won't understand how that's impacted. If I see a cookie that might alter how the features might function, what happens if I delete that cookie? Can I alter that cookie? What happens if I've got claims inside the token that give different permissions that I may not have access to or have never seen? How can we test for that kind of stuff? Recon is one of the most important things when doing API security testing. And it's important that we're doing that. And unfortunately, a lot of people neglect this, which is why they don't get the right impacts that they're looking for when they're doing their security testing. The other thing to think about too, though, is that in an API world where we might have a lot of API spec docs, maybe this is Open API, this could be Swagger, where they're going to define how the endpoints are supposed to function. They're going to be able to put constraints on these endpoints and the data and the objects that are being there. So as an example, as you see here on the screen, here's a scenario where we can see a product object where the price actually has a pattern that has been applied to it. The question is, just because the API docs say it's that way, was the implementation actually to that as well? You need to test against that and verify it, because the docs don't always tell the truth. And so it's important to verify that the actual API usage works as intended. Maybe that's not a string. Maybe it's a float or a double. Maybe that pattern can actually be abused to give you other access. And this is where things like taint analysis and ability to abuse these endpoints with things like the naughty string database, where we can inject other patterns and see how the objects may, how the APIs will respond. very important that we're doing this. If we have integers, we should be doing bounds checking to make sure what happens with a negative or positive that's out of range. What do we do in those type of scenarios? Testing for this is important, but a lot of times during the recon process, people aren't figuring out what are those bounds, what are those resources look like, how do those objects function, and do they match up with what the docs say they do. The last thing we're thinking about negligence is this whole aspect that people fail to track API changes and drift. As we continue to mature the API security testing, we're going to want to be able to early detect when changes occur that might impact us. Now, there are tools designed specifically to do this. Things like OSDIF can really help with this because you can take the existing API spec doc and compare it with a newly published one and look for changes. This can all be automated so you can be alerted about when a change is detected, such as an endpoint that's changed or maybe a new one that's been in place, to give you early access and early warning to areas where you might want to go and do some further testing. And a lot of times people aren't leveraging this and they don't take advantage of that. And that's disappointing because in many ways you'll be able to get a foothold into these APIs even sooner by understanding what's changed even before the development group may tell you about it. Sin number 4 is around chaos. It's this aspect that in many cases, people don't follow a plan, and that becomes a main problem. It's also disappointing because it's well defined and documented out there. OWASP is been out there for a long time telling us the type of ways that we should be doing testing, especially when it relates around this stuff. So when the sin is we're failing to plan, the reality should be we should be planning to fail. And we can take guidance from places like OWASP to do that. As an example, OWASP publishes the API Security Top 10. This is great guidance to tell you what are the top 10 classes of vulnerability that we're seeing in the field. But that in itself isn't really a standard. That's just really recommendations and guidance. It's table stakes. You need to be doing this. If you're not doing this, it's kind of moot to worry about having to go deeper into your testing. But that's not where it ends. And you see lots of vendors trying to sell API security about the API Security Top 10. That's just a small fragment of what really should be tested. And this is where things like the application security verification standard come into play because they provide a much more detailed and granular look at the type of things you should be testing. And there's actually an entire section V13, that's dedicated to API security. Just to give you an example what that looks like, here's just a small snippet of a few items. If you look at V13.1.3, there's a specific test where you're to verify that API URLs do not expose sensitive information such as API keys, session tokens, etc. And what's really nice about this type of guidance is that the ASVS standard actually includes the CWEs, the common weakness enumerations, that can tell you, based on this test scenario, what are the weaknesses we're validating against. And what's nice is that when you can map it to that CWE, it gives you the ability to provide guidance on how to mitigate these type of issues, which can help developers to get more informed information as you're doing your security testing. And we'll get to that in a couple minutes. When you don't have that kind of plan, though, we start seeing uncoordinated and haphazard testing efforts, and it actually hurts the whole process because we start seeing things like irregular testing schedules, and when you're not testing in alignment with what the development group's doing and on where release cycles are, there may be areas or gaps where the window of exposure of a potential vulnerability may be a lot more than we want it to be, simply because we're not properly testing at the right time. What's worse, though, is that when we go through that testing, a lot of times people lack the ability to track those results and make sure that those issues and vulnerability reports get into the defect tracking system. So we want to make sure that part of our test planning also has a good reporting. And if we don't have that, it's chaos because now we won't be able to communicate well with the team, especially when the developers need to understand what is their exposure when it comes to security testing. The fifth sin I want to talk about is about overambition. It's about basically testing too much because you get so excited about wanting to actually get involved and do security testing, but sometimes it's just not possible to get the right coverage that you need. And that really comes down to this idea of like, you can't boil the ocean. You can't get everything done at once. You got to start somewhere. And overambition it can kill so many different security programs that are out there. Because if the security testing is trying to get too much coverage and provides too much false positives or too much noise, it won't be trusted and it won't get the work done that needs to be there. When we start thinking about what we want to do, you need to start small. You really want to be thinking about getting test coverage in the areas that have the most concern. One of my recommendations is that you start with authentication, authorization, and session management, because all your API endpoints will have some sort of validation against there. And more importantly, it is much harder for drive-by attacks into the APIs unless there's some sort of authorization and authentication model where they need to have an authenticated user, which limits and reduces the potential risk and the blast radius of any vulnerabilities that are there, because it has some requirements of having access to the system in the first place. That doesn't mean we shouldn't look in other places, but when we first get started, we should take small bites and just do small areas, get it done, and then learn from that, iterate, and then improve. The sixth thing I want to talk about is blame. And that's really about creating a dangerous feedback loop. And there's this problem that I see these days, which is this us versus them mentality, where security engineers and security testers are in a position where they make the development group uncomfortable and provides an environment that isn't safe, not just psychologically safe, where people are able to be honest and have conversations about the vulnerabilities that are being found, but being in an area where they're going to trust the work that you're doing and they want to work with you. Because one of the biggest things we want to do is make sure that the dev teams are our advocates, not our adversaries. And that means that we need to make sure that we're helping them and we're not hindering them. Because if we get to a point where they feel threatened, they're going to be in a position where they'll be more resistant to our input and to our reports. And it's important that we work with them, not against them. So how do we do that? Well, we want to help them and we don't want to hinder their work. So the best thing we could do is things like include proof of concept exploits in our vulnerability reports. This has a couple of different things that it does for us. The first is it allows the developers to be able to run the test to see it for themselves. If they can see an exploit that actually is against their system and they can rerun that, that helps them a lot. The second thing it does is it helps to demonstrate damage potential, and that helps them to understand and prioritize what needs to get fixed first. The second thing is do that root cause mapping. We're talking about using those CWEs in the ASVS. Do that. Provide the developers with the information, link to the CWE so they have some guidance on how they should go about fixing the vulnerability. This helps them and it helps you because we're talking the same language. We're communicating about what the root cause is to that vulnerability and how to go about mitigating it. Then that helps us because now we can start discussing how to create SAST rules for future detection so that not only are we looking at this individual vulnerability, but now we can start applying SAST rules to look for this vulnerability class. So hopefully in the future, we can reduce the chance or likelihood that this vulnerability will be found in another place. Our final sin is around faith. Too much trust in vendor products. You know, we were talking about this whole aspect of SAST and DAST, where vendors have built some very good technology to help on there. But when we're talking about HAST, we're still using vendor technology there. But the reality is the majority of the testing that's going to find the deepest, most impactful vulnerabilities, they're going to come at the HAST level. And so that means that we can't just trust the vendor tools. And that's because security testing is a process. It's not a product. And if you have that test plan in place, that process should be able to be driven and supported by the product. It's not something you can buy, but at the end, the product results should come as outcomes of that process. In other words, if the products don't have the capability to be able to support the test plan and provide the information and the outputs to allow you to know for sure, have we tested for this scenario and are we in a good position, then maybe that's not the greatest tool to be utilizing. And if it's not giving you that type of output right away, you need to question the value of the tool that you're buying. So where are we? Well, at the end of the day, we just talked about these 7 sins. But I think a better way of looking at this would be to not think about it from the negative side, but the positive side. You know, how do we look at this? How do we approach this? In other words, we need to start our testing today. We need to be figuring out what makes the most sense for our teams. Should we start with HAST? Should we start with SAST? Should we be implementing it at different areas? And where do we want to do it that's going to add the most value to the system? We want to inventory the APIs, make sure we actually have visibility of where they are and how they're being consumed. We want to recon those APIs and make sure we fully understand how they function, how they work, how does the apps consume the APIs, and how does it ultimately function, and ultimately how's that data move throughout the system in the APIs. Of course, build that test plan, leverage the OWASP guidance, not just of the OWASP API Security Top 10, but the actual ASVS, especially in Section 13, to make sure that we understand, are we testing for the right stuff? If you think about it, the OWASP API Security Top 10 has less than 50 security controls that are in play to validate against those 10 vulnerability classes. But the ASVS L1, which is meant for is considered the bare minimum that OWASP publishes, has over 120. And if you move into L2, where APIs really should be tested against, that level 2, there's almost, I think, 200 different security controls are in there. And each endpoint would need to be validated against those controls to find out what works and what doesn't. So in the end, a lot of work that needs to get done. You have to build that test plan and follow it. Start small, though, and iterate. You can't test everything across the entire API. So start with small places, the ones that are most critical, and then continue to develop and increase and improve that. Help the developers, don't hinder them. Give them the tools and information that they need so that they can remediate the vulnerabilities quickly so you can move on and continue to get on there. And finally, you can't buy your way out of security testing. It takes work. It takes effort. Leverage those tools. Find the tools that will help and assist you to deliver on your test plan. But in the end, don't trust that the vendors will have a tool that will solve everything for you. They just don't. They can't understand how the APIs and the business logic is truly going to work. So that's about it. The one last thing I want to talk about, though, is that if this kind of stuff's interesting to you, I want you to head over to apihacker.blog. That's my free weekly newsletter where we talk about API hacking and security testing like this all the time. And I hope you'd want to join. Check it out and let me know the feedback on what are the type of things you want to learn when it comes to API hacking and the security testing of those components. And that's it. I did it in time.
So much. That's golden advice. All of that's really great. Make sure to check out the free weekly newsletter. HAST, I'm using that from here on out. Like,
hey, manual testing is just such a bad word because
it is.
We can automate so much stuff, right? Like I'm just looking at some of the comments now and I see people are asking like, well, how would you use Postman to do that, right? It's like, well, actually think about it. Postman gives you the ability to create requests. Those requests can have pre and post execution tests. Those tests could have variables that could be injected in there. So when you run the Postman collection runner, it can automate that entire thing. And I actually have a blog post to demonstrate how to use like the big naughty string list to do like malicious injection throughout entire requests. You could scale that up and build out an entire collection that could be testing all the different endpoints in all the different ways, all automatic. And that's a great, powerful way of being able to do that. So yes, you have to manually create that test the first time, but then you can run it. And then you can use tools like Newman and actually plug this into the CI/CD pipeline as a security guardrail so that as people are trying to move changes in the APIs into an environment, all those tests can run to verify that they'll be validated, right? The other side too is that when you find these vulnerabilities, it becomes the best regression testing ever because you've been able to demonstrate and give to the developers the vulnerabilities in some sort of form of an exploit. You know, maybe that's in Python, maybe that's just a bash script that's got curl in it. I saw someone ask, like, how would you give them an exploit? Like, well, if you can actually produce a post or a put that can cause something to occur, there's no reason that that can't be exported through Burp Suite or that into a curl command. And you can just give that to the developer and they can repro that at any time. So yes, HAST is important and we should be doing more of it. And there was never a good term for it. So I decided I'd call it HAST years ago and it's stuck for me anyways.
That's great. Yeah, it's going to stick for me as well. Yeah. Also, your advice at the end of not depending on a single tool or the latest and greatest single device that's going to fix all the problems. with a lot of those, you can actually go into the CWEs, and a lot of those tools will say which ones that they test for.
Yeah, absolutely. And what's interesting too is that MITRE's done an amazing job of mapping everything. So if you start looking at this, you take the OWASP guidance for ASVS, that goes and points to the CWE. You go into the CWE, and inside of that CWE, there's usually a CAPEC, which is the common attack patterns and classifications. So in other words, not only can you provide the developers with details on how to mitigate or fix issues through the CWEs, as a security tester, you have the ability to learn what are the attack patterns that are actually being seen in the real world against that CWE. So it's interesting because it means that you could look at the ASVS, look at what they say of the CWE, and if you don't know how to test for it, you can follow into the CAPEC and get the attack pattern to build in, and then figure out, okay, how would I construct that through Burp Suite or through Postman to be able to replicate that attack, and then codify that in a way that you can then further test that going forward.
Great. Yeah, I see we have a couple minutes before Jose Peralta hops on. We do have a few questions. Let's see. Let's go with this. I think you touched on this already, but could you please explain how to test and exploit SQLi or blind SQLi in Postman?
Yeah. So if you had, so let's say you've constructed your request and you built out a request, or let's go a different way. Let's say the developers have given you a OpenAPI spec doc, which you've imported into Postman. So now you have the actual normal requests. You would create a new collection and you would export that so that you can modify it. Never touch the original collection. Never modify it. Those are the developers, and you want to know what is their happy path. What do they expect it to do? But in your collection, that's where you get to have the fun. So you can then take that and do things like codify or parameterize things like, hey, if I know that the payload has the ability to take in user input, I can use that as an injection point, and then I can then set up my database of known understandable injections and run that through there. That's one way to automate it. Of course, someone else had mentioned it like, well, but it'd be nicer to do this in Burp Suite. Well, Postman has the ability to actually route through a proxy. So that means that you could take the request, route it, run it through Postman, and it'll go through Burp Suite. And then you can take that, put it in the repeater tab or intruder, and then you could, do what you would normally do as part of that attack vector. Things like Burp Suite also have the ability through its extensions to take that even further. As an example, if you're not very good at SQL injection and you want to get some aid to that, you can use things like SQL map that are mapped in as an extension that could go right in to the requests. So this gives you the ability to run the original thing through Postman. And if you want to, you can alter the test to inject the type of data that you want to validate. So those SQL injection strings, the payloads that you know, and you could apply them and run them in there, and that could run automatically. But if you want to force that request through Burp Suite, then you can go into Burp Suite and use its extensions to then further take that on. So you might have an intruder payload that, mechanism to go and attack it, or you might use an extension like the SQL map extension that will do that injection testing for you. It's really up to you on how you want to move forward in that kind of thing.
That's awesome advice. Thanks so much for joining us and presenting on this. Really love the presentation.
Awesome. Thanks for the invite. Have a great day, guys. I'm going to stay in the comments and I'll chat with some people as I can. Enjoy the next talk.